Okay, so today we're going to continue on in section 6.7. For the most part, today is the exact same thing as we did yesterday. Okay, there's only two new things that, not necessarily, well, they are new, but two things we have to look out for. But everything else, like I said, is going to be the same ideas, even the same process we did yesterday, just maybe a little bit harder. Okay, so two things we're going to look out for. I'm going to type them because you guys know how great my handwriting is. Okay, so first thing is when you divide polynomials, we have to make sure and arrange them in decreasing degree of the variable. Which probably sounds like a bunch of math jargon. You have no idea what I'm talking about, so I will explain it to you. When you divide polynomials, arrange them in decreasing degree of the variable. Okay, here's what I mean. Sometimes we get a polynomial and it's not in the correct order, right? The squared term is at the end, maybe the constant's at the beginning, or the cube term's in the middle, right? If they're not where they're supposed to be. When you're dividing polynomials, if you get a polynomial that's not in the correct order, you have to put it in the correct order first. Okay, so you're going to find your highest powered term. So if you're working with x's, you're going to look for the highest exponent that any x has, and you're going to work your way down. Now you do have to be careful, because if there's signs involved, not all of them are positive, not all of them are negative. When you move them around, you have to take the signs with them. So you're looking at the sign in front of the term. If it's negative, if it says minus 2x squared, you need to move a minus 2x squared where it belongs. Okay? So take the sign in front of it. Okay, that makes sense? Okay, so put them in order. Okay, and then the second thing, which is the super new thing, because we have actually talked about putting things in order. The second thing that we have to look at today is also we're going to have to use a zero coefficient to insert missing degrees in a polynomial. Which, once again, probably doesn't make any sense. You have no idea what I'm talking about. But don't worry. I'm going to explain this one too. So use zero coefficients to insert missing degrees into a polynomial. Okay, sometimes we have a polynomial that's out of order, and then sometimes we have a polynomial that it's not out of order, but there's just really not much to it. Maybe it's just an x cubed minus 1. Okay, well that's an order, right? I have an x cubed. I don't have any other x's, so then my minus 1 comes afterwards, right? And here's the thing, when you're doing polynomial long division, this doesn't really work very well, and we'll see in one of our examples today why this isn't going to work. What we have to have is if I see an x cubed, I have got to be able to see an x squared and an x and then a constant. If I don't, I've got to use a zero coefficient to kind of use as a placeholder for my x squared term. I've got to use a zero coefficient for my placeholder for just my x term. Okay, so what this will look like, if you have an x cubed, you know you're going to need an x squared and an x. If you don't have an x squared and an x, we're going to rewrite this polynomial as x cubed plus 0x squared. And the reason we can do this, what is 0x squared? It's just 0. So I'm not really changing it, okay? But I can now see that I have an x squared. And we're going to do the same thing with my x. So plus 0x, and then I have the minus 1 at the end. Okay, and you guys, it may not make sense now, but once we get into the example, you'll see why we have to do this, okay? So if you have a y to the 5th, somewhere along the way, whether it was given to you or you writing it in, you should have a y to the 4th, a y to the 3rd, a y squared, a y, and a constant. Maybe not necessarily a constant, but you need all of those powers of that y. Okay, does that make sense? Okay, those are the two things we're going to look out for today. Everything else is the same. The process is the same. The dividing is the same. All of that good stuff. Okay, ready for some examples? Excited? Yeah. Yes? All right. Number 1. 7 plus k squared minus 4k over k minus 5. Okay, let's look at this problem. Gaze adoringly at this problem. Appreciate it. What's wrong with this problem? Okay, it's not in order. So we don't necessarily have to change it in its order as you see it here. But when you go to set up your division problem, then go ahead and fix it. So we have our big division sign. We're going to put that numerator on the inside. Which of those terms will come first? Right, the k squared. And it was a plus k squared, so it is going to be a positive k squared. What comes next? Minus 4k. Notice how the minus stays with the 4k, and then what? Plus 7. And you kind of have to do the same thing with whatever you're dividing by. Usually it's in the correct order. You don't have to do anything with it. But if by some chance it was in the opposite order, you would have to switch that around too. Okay? Now this part is literally the exact same as yesterday. This is just like a problem we did yesterday. So looking at the first terms and the first terms only, k times what gives me k squared? K. And then we're going to take that entire k minus 5 and multiply it by k. K minus 5 times k gives me k squared minus 5k. Okay, so we multiplied. After you multiply, then you're ready to subtract. Now, although I said this over and over and over and over and over again yesterday, I still have people doing the incorrect thing today. Don't try to do the multiplication and subtraction in the same step, because I promise you'll screw up somewhere along the way. Multiply and then subtract. And remember, whenever you subtract, you have to subtract that entire thing, right? K squared minus k squared. Those cancel out. And then negative 4k minus a negative 5k. That minus a negative turns into a plus. And negative 4k plus 5k gives me just a k. And then we're going to bring down the plus 7. Okay, and now we're ready to do it all over again. Looking at the first terms only. K times what gives me k? A plus 1. And k minus 5 times 1 gives me k minus 5. And then we're going to subtract after we multiply, and we're going to subtract the whole entire thing, right? K minus k, those cancel out. 7 minus a negative 5, the negative 5 turns into a plus 5. And what do I get? 12. Very good. Okay, well now I'm finished. I don't have anything else to bring down, so I'm ready to write my remainder. What would my remainder be on this one? Very good. 12 over k minus 5. All coming back to you? Yes. Okay. Questions on number 1? Okay, so really not any different from what we did yesterday. Just got to rearrange it. The dividing is the same. Okay, this next one's going to be one that is even a little more different. Okay, this one, 8y squared plus 6 over 2y minus 1. Okay, while you stare at this problem, appreciate this problem, what do you notice that's wrong with this one? Abby?
You can find the greatest common factor in the numerator.
Okay, you could factor out a greatest common factor. We could. We are not necessarily going to do that. It would kind of throw some problems into our division. What do you notice, Tara?
There's no y.
I'm missing my y, right? If I see a y squared, I also need a y, and then I also need a constant. So if I don't have a y, I need to use a zero coefficient to kind of use it as a placeholder. So once again, don't necessarily have to write it in the numerator there, but whenever you go to write out your division sign, if I have an 8y squared, I also need a 0y and then a plus 6, okay? Have to have all of those degrees there, and then the 2y minus 1 on the outside. Okay, and then this is the same as yesterday. It just gets a little more tricky because you got numbers involved. 2y times what will give you 8y squared?
4y.
4y, but the same thing as yesterday, right? You're going to take 4y times 2y minus 1, and we get 8y squared minus 4y. Okay, and now, once again, we're not going to mix up the multiplication and subtraction steps because we know we'll make a mistake if we do that, so we're going to keep them separate. After I multiply, then I'm going to subtract. Now, here's what I want you guys to notice before we go through and finish this one. I want to show you why we need that placeholder. If I did not have this 0y here, I would have a 6 here. And I would be trying to subtract 6 minus 4y, which we all know you can't do, so they would have to stay separate, and it would look kind of confusing. And for this one, it would probably turn out okay, and we could probably figure it out. But when we get larger polynomials with more terms, it would get really confusing. So if you use this placeholder here, you see how my y's are lined up, the like terms are already lined up. That's why we use the 0 placeholder. Okay? So now, we're ready to subtract, and we're going to subtract everything. 8y squared minus 8y squared cancels out. And then whenever I subtract a negative 4y, what do I get? Just a positive 4y. And then bring down the plus 6. And then we get 2y times what gives me 4y? A plus 2. 2y minus 1 times 2 gives me 2y minus 2. After we multiply, then we will subtract. Okay, and we're going to subtract that entire thing, right? After we multiply 2y minus 2, then we're going to subtract, and we're going to make sure we subtract the entire thing, right? Oh, I didn't multiply, did I? Okay, 4y minus 2. Whenever we subtract, my 4y's cancel out, which should happen, and we're going to make sure we subtract everything so that minus 2 turns into a plus 2. What am I left with? And 8. I have nothing left to bring down, so ready to write my remainder. What's my remainder for this one? Plus 8 over 2y minus 1. Very good. Questions on number 2. Okay, I'm going to let you do the last one on your own, but I'm telling you guys right now, do not mix the multiplication and the subtraction into one step, because this next one, I promise you, if you mess up, if you're not getting the right answer, it's because you're not subtracting everything, okay? So be very, very careful with your subtraction on this last one here, okay? All right, this one, let's have w cubed plus w squared plus 2w minus 4 all over w minus 1. Okay, and before you guys start this one, is there anything wrong with this one? Nope, because I have a w cubed, so I should see a w squared, which I do. I should see a w, which I do. And then I have my constant. It's all in order. It looks very pretty, so go ahead and start dividing. Okay, if you think you have the right answer, check with what I have on the board. If you didn't get that, you're not sure why, let me know.